Today's lesson is on similar polygons. And so our essential question is, how can I use similar polygons to find missing sides of a figure? So first, let's figure out what it means to have similar polygons. So polygons are considered similar if their corresponding angles are congruent. So the angles that match each other have to be equal, and their corresponding sides are proportional. So let's talk about proportional. Proportional, does that mean congruent or equal? No, proportional is when you are multiplying by a number to get another number. So if all the sides are multiplied by 2 to get the sides of the other figure, then those sides would be proportional. Okay, or if you start with a larger figure and the sides are scaled down by 1/2, then if all the sides are scaled down by exactly 1/2, then those would be proportional as well. Now, the similarity ratio is the ratio of the lengths of the corresponding sides of similar figures. So like when we were just talking about having a large triangle and a small triangle that have, let's say, here we'll draw one. We have a larger triangle and a smaller triangle. And this side is 6 and 3 and 4 and 2 and 2 and 1. So I can look and I can tell that to get from 6 to 3, I'm cutting it in half. To get from 4 to 2, I'm cutting it in half. And to get from 2 to 1, I'm cutting it in half. So because all of the sides are being scaled down by 1/2, then the similarity ratio in this case would be 1/2. So whatever you're multiplying by to get the new sides, as long as they're all the same number, that would be the similarity ratio. So it says determine whether the triangles are similar. If they are, write a similarity statement and give the similarity ratio. So we have here two triangles, kind of like in our example above. And we have to determine whether these triangles are similar. So remember our definition of similar polygons. The corresponding angles must be congruent. So let's check. So angle A matches with angle D. Those are both 90 degrees. Angle B matches with angle E, and those are both marked with 2 arcs. And angle C matches with angle F, and those are both marked with 1 mark. So all the corresponding angles are congruent. Now we need to check to see if the corresponding sides are proportional. So we need to look and see if these 3 are somehow related to these 3 by multiplying all 3 sides by the same number to get the other figure. So we're going to take a look at 12 first. So 12 matches with 16. So if I take 12 over 16 and I put these numbers into a ratio or a fraction, I can reduce this in the simplest terms. So I could divide both of these numbers by 4 if I wanted to reduce. So then I would get 3/4. Okay? So now let's take a look at our other sides. I have 18 and 24. So let's compare those. So I have 18 compared to 24. And I can divide both of these numbers by 6. Sorry, that looks like plus. Divide. So we've got dividing by 6, dividing by 6, and so we get 3/4. Again, so far so good. So now I'm going to take the last pair of sides, 15 and 20, so 15 over 20, and I can divide each of those by 5, so I get 3/4. So because all of these numbers are the same, I know that my corresponding sides are proportional. They're all multiplied by 3/4 to get the other triangle. So it says to write a similarity statement. Okay, similarity statement. So you've done congruent statements before where you say that two figures are congruent. Well, now instead of saying that two figures are congruent because one is larger than the other, we are going to say that they are similar. So the symbol for similar, if you want to know that, the symbol for similar is just a squiggly line. So this right here is the symbol for similar. So I see that triangle ABC is similar to triangle DEF. That is my similarity statement. Okay. Similarity similarity statement. And it also asks for the similarity ratio. When I did all my comparisons of my corresponding sides, I got 3/4 as the ratio. So my similarity ratio is 3/4. So it can be written as a fraction or you can use a colon. Okay, so let's apply this to some proportions and missing sides. So it says LMNO is similar to QRST. These are both trapezoids. And they want us to find the value of x. Okay, so I can look and I can compare. I know these are similar already. They've already established that for me. So I know that their corresponding sides have to be proportional. So therefore, I can write a proportion to solve for x. Now there are lots of correct ways to write your proportion for these. You just have to make sure that you're consistent. So if you want to go from left to right using like 2 and x, that's totally fine. But then the second time you write your numbers, you still have to go from left to right. Okay, if you want to go from top to bottom, that's totally fine. But then on the second figure, you have to go from top to bottom. You have to go the same direction both times that you're setting up your proportion. So let's say that we're going from left to right. Well, I know I'm trying to solve for x, so I need to use this side, which I see matches with 2. So I'm going to write 2 over x equals, and then I'm going to go from left to right again. So I'm going to pick my other pair, and I'm going to do 5 over 6. So 2 over x equals 5 over 6. Now I have my proportion, and I can go ahead and work it out. And I learned last time that to solve proportions, I can do the shortcut of cross multiplying. So 2 times 6 equals 12. And then 5 times x equals 5x. So I'm going to divide by 5. And so I get x equals 12/5. And you are more than welcome to write the decimal answer for that if you'd like, but I'm going to go ahead and leave mine as a fraction. So I just cross multiplied, and that's how I got x. Now, you could do this same problem, get the same exact answer by setting up your proportion differently. So let's say that instead of using that proportion, I have a different one. So let's go from top to bottom this time, just for fun. So 2 over 5, I use this one, 2 over 5, equals, and then I have to pick another one over here. I have to go from top to bottom, so I have to go from top to bottom. X over 6. Well, if I look at this, when I cross multiply, I'm still cross multiplying the same exact numbers. I still get 12 equals 5x. So I'm still going to end up with the same answer of x equals 12/5. So it does not matter how you choose to set up your proportion as long as you go the same direction both times, like top to bottom, or left to right, right to left. Just be consistent. All right, one more thing that's kind of cool about proportions. There's a lot of proportions in art and architecture. The golden rectangle is a very famous proportion that's used in Greek architecture and also lots of art. And it's a rectangle that can be divided into a perfect square and a rectangle that is proportional to the original. So for example, if I started with this particular rectangle right here, I could divide it right here so that there's a square and a rectangle. And this rectangle is going to be proportional to my original rectangle that I drew. And I can keep dividing it and dividing it and dividing it. And so it's kind of cool how it works. So the golden ratio is the proportion 1.618 to 1. That is how the golden rectangle, that's the similarity ratio for the golden rectangle. Okay, so the longer side is 1.618 and the shorter side would be 1. This was derived by comparing the corresponding sides of the golden rectangle. So how can I use that? Okay, well, an artist plans to paint a picture. He wants the canvas to be a golden rectangle with its longer horizontal sides 30 centimeters wide. How high should the canvas be? Okay, well, we can use our golden ratio as part of our proportion. And then we've also got this number here. Okay, well, I know that if I break this down, this question, I know the longer horizontal side is 30 centimeters. Okay, well, in my golden ratio, what is my longer number going to be? Is it going to be 1.618 or is it going to be 1? Well, obviously it's 1.618. So when I'm setting it up, I'm going to match up the parts that go together. So I'm going to match the longer side with the larger number. So if I use 1.618 to 1 as my golden ratio, then I need the longer side to be on top because the larger number is on top. So 30 is going to go on top. But I do not know how high the canvas should be, so I'm going to use X to represent that. Okay, so to solve this proportion, I'm just going to cross multiply. So I get 1.618x equals 30. And so then to solve, I would divide by 1.618 on both sides. So 30 divided by 1.618 is approximately 18.54 centimeters if you round to the nearest hundredth. Okay, so I don't have an exact answer because I get kind of a long decimal, but that would be my approximate answer. Okay, you guys can use this to go ahead and go back and answer the essential question to write your summary. And please make sure to write 2 potential test questions on the left-hand side. Thank you.